Hello everyone, welcome to our today's class on gravitation. So have you ever wondered that when you drop something, why it always fall down, why not up or why not sideways? Similar question came to Newton's mind. The story goes to that when he was sitting under an apple tree, an apple fall on his head and it made him curious that why this apple fall straight down. And this curiosity led to the greatest discoveries in history of physics that we call gravitation. Now, when you drop something, initially it will be at rest. So, from Newton's law, we know that to start a motion in any object, a force is required. So, when you are dropping something, why it is going down means something applying force in downward direction, and in our case, Earth is applying force on that apple. That's why it is going down. And Newton didn't stop here. He had some bigger ideas. He thought that what if this force is not just limited to apple and the earth? What if force uh, this force is acting between every two bodies in the universe? And then he gave the idea about gravitational force. So how strong will be that force? This is given by Newton's universal laws of gravitation. So its statement says that uh, force of attraction force of attraction between two bodies having definite mass having definite mass is increases as you increase the mass and decrease rapidly decreases rapidly when you increase the distance between two bodies. So from this statement we can conclude that force of attraction between two bodies is directly proportional to product of their masses and inversely proportional to the square of distance between these two bodies. Suppose I have two masses. This is mass m1 and this is mass m2, and center to center distance between these two masses is r. Why center to center distance? Why not from this surface? So if you are dealing with bigger bodies like planets, so if you are taking distance from this center, and in one case you are taking distance from surface, so this distance in case of planets is in thousands of kilometers, so it will make a huge difference. And one more thing, that we assume that all the mass of any body is concentrated at center. That's why we are taking center to center distance. So now this mass is m1 and this mass is m2, and distance between these two bodies is r. So force of attraction is directly proportional to product of their masses and inversely proportional to square of distance between them. This is equation 1, this is equation 2. From equation 1 and 2 we can write F is directly proportional to m1 m2 upon r square. As you know that to replace this proportionality symbol with equal to sign, we have to add one constant, and that constant is g. So this equation becomes g m1 m2 upon r square. This g is universal gravitational constant, universal gravitational constant, and its value is 6.67 into 10 raised to power minus 11. We will see how to derive its unit. I am raising this part. So if you write this equation in terms of G, so it becomes G equal to F into R square upon M1 into M2. So unit of force is Newton, unit of distance is meter square, and unit of masses is kg square. So unit of gravitational constant is Newton meter square per kg square. So I can write value of G is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. Now we will discuss one more important thing. Why do moon orbits the earth and why do other planets orbits the sun? And before finding its answer, we need to understand something important called centripetal force. So as we know from Newton's first law, anything in is in the state of straight line motion continues its straight line motion until an external force applied on it. So to change the direction of motion of any object, we need to apply a force. So suppose if you want to move an object in a circular path, you have to apply a special kind of force that can change its direction continuously, and that special kind of force is called centripetal force. Centripetal means center seeking, means towards center. Now consider you tied a stone with a thread and you want to move that stone in a circular path. So if you are moving that stone in a circular path, I am drawing its trajectory. So when the stone is in this position, its velocity vector, its velocity direction will be in right to left direction. In this position, its direction will be from top to bottom direction, and in this case, left to right, and here bottom to top. Now, direction of velocity is this. So, why it is not going in this direction? Why it is changing its direction? Means something applying force on this stone. That's why it is changing its direction. So, what thing is applying force on that stone? Obviously, this thread. This thread is applying the force on this stone towards this point O, and this force is changing its direction from this to this. So whenever any object is moving in a circle, uh, its velocity may be constant or different. In case its velocity is constant, its velocity speed is constant, its velocity is changing its direction, means it is accelerating. If it is moving with same speed, still it is its velocity changing its direction at every point. This means it is accelerating, and if there is acceleration, there must be a force from Newton's second law. If there is any acceleration, there must be a force. This force is centripetal force. So this thread is providing the required centripetal force to this stone so that it can move in a circular path. Now what will happen if this thread cut if we cut this thread? What will happen? That stone will fly away in a straight path. Like if its thread cuts in this position, it will fly away in this path. Now This is sun. Here Mercury, Venus, Earth, and more planets. They revolve around the sun in almost circular path, not exactly the circular path, but in almost circular path. Then what thing is doing work as that thread? So in that case, answer is gravitational force. Sun is heavier object, so sun is applying force on these planets towards itself, like that thread was applying force on that stone towards the center. Similarly here, sun is applying some force on these planets. That's why they are moving in a circular path instead of a straight line motion. Now what will happen if somehow we can stop this gravitational force? Then these planets will fly away in a straight line like this one. So conclusion is that for anything to move in a circular path, the centripetal force is required. I hope this gravitational force is clear now. Now one question. If I am dropping this marker, it fall down, earth is applying some force on it, that's why it is going towards the earth. Now is it also applying same force on the earth? Obviously yes, from Newton's third law. If any body applying some force on another body, then other body will also apply same magnitude force but in exactly opposite direction. So when earth is applying force F1 on that marker will also apply same magnitude force on earth but in opposite direction, like force direction of earth is towards top to bottom and force on earth due to marker is from bottom to top. Magnitude of both the forces is equal, but why this marker is going down only? Why earth is not coming towards the marker? So answer to that question is from Newton's second law. Force is same in both the cases, so I can write F1 means force by earth on marker. I can write this as mass of earth and acceleration of earth, and this second force on earth due to marker, I can write this as Fm equals to mass of marker into acceleration of marker. F equal to Fm from Newton's third law. So I can write MEA equal to MM. So acceleration of marker upon acceleration of earth will be equal to mass of earth upon mass of marker. So if we take this ratio, mass of earth is very huge in term if we see in comparison to mass of marker, this will come around 10 raised to power 24, and it will, so this thing will also come around 10 raised to power 24. So I can write acceleration of marker will be 10 to the power 24 times acceleration of earth. That's why we can observe only acceleration of that marker, not the acceleration of earth, because earth is very heavy object, so its acceleration will be very low. For a same force, suppose this is 10 Newton and it is also 10 Newton. For a fixed force, same force, if mass is more, acceleration will be less, and if mass is less, acceleration will be more. Like you can think it about like that. 10 equal to, if in one case I am taking mass as 0.1 kg, So to make it equal to 10, I have to multiply this with 100. Now take another case. If I am taking here 1000, so I have to multiply here with 1 upon 100. That's why this is acceleration, and take this as mass. So if mass is high, acceleration will be very less. That's why we can observe acceleration movement in earth only, movement in marker only, not in the earth. Now we will discuss about properties of gravitational force. Properties of gravitational force. First is long range force. Gravitational force is acting between short bodies, as the distance between this marker and the center of earth is not it is high enough, but in case like Jupiter and other planets, these planets are millions kilometer away from the sun, and gravitational force is acting between these two bodies. So we can say that gravitational force can act up to infinite distance. As Jupiter is doing orbits around the sun, that means sun is applying some gravitational force on the Jupiter. That's why it is doing circular motion around the sun. So we can say that gravitational forces are long range forces. This gravitational force can acts between very near bodies and as well as very far bodies. Always attractive. Gravitational force always attracts two bodies. Like if this body is applying gravitational force on this body, it will always attract this body towards itself. It can never repel. In case of magnetic force, we have south pole and we have north pole. Characteristics of these two poles are opposite. That's why if you have one south pole, one north pole, they will attract each other, and if you have like poles like north pole and north pole, they will repel each other. There are two kinds of poles, then so that this magnetic force can be attractive or repulsive. But in case of gravitational force acts because of mass, and mass has no polarity. It is like, you can say, it is always positive, it can never be negative, and it has no polarity. That's why this gravitational force is always attractive. Third force is weakest of all fundamental forces. We have fundamental forces like electromagnetic force, nuclear force, gravitational force, and this gravitational force is weakest of all the fundamental forces. Uh, it gives significant force if bodies have very huge mass, and but if we see in case of electromagnetic force, uh, like two protons have very less mass in the range of 10 raised to power minus 27 kg, still force between them is observable. But here you cannot observe the gravitational force if masses are very less and if distance is very high. Fourth is non-contact force. Gravitational force does not require any contact. Uh, Moon is orbiting the Earth, and there is no physical rope between Earth and the Moon. Still, the force is acting between the two bodies. But in case like contact force, in contact forces, take its example as uh, friction force. So suppose you have a very rough surface and you are pushing a book on that rough surface. You are pushing the book in that direction. So friction force will act in opposite direction, and this friction force will act only if there is a contact between this surface and this book. Friction force cannot act without the contact between two surfaces. Like if you, in one case, I am pushing this marker on my hand in contact with my hand, then friction force will act. And if there is no contact between my hand and this marker, then friction force will not act. So these forces which requires contact between two bodies, these forces are those kind of forces called contact force, and those forces which do not require contact between two bodies are called non-contact force, like gravitational force. And gravitational force is central force. Gravitational force is central force. It acts between the line joining the two masses. It will act in the direction the line joining the center of two bodies. It will act in this direction. Clear? So we will discuss some numericals. First question is, find gravitational force. Find magnitude of gravitational force between a proton and electron. Mass of proton is 1.6 into 10 raised to power minus 27 kg, and mass of electron is 9.1 into 10 raised to power minus 31 kg, and take distances placed at 10 raised to power minus 10 meter distance. So distance between these two bodies is 10 raised to power minus 10 meter. So gravitational force is G m1 into m2 upon r square. Value of G is 6.67 into 10 raised to power minus 11. m1 is 1.6 into 10 raised to power minus 27, and m2 is 9.1 into 10 raised to power minus 31 upon 10 raised to power minus 10 square. So take all these numbers together and take all the 10 powers together, then it will be easy to solve. So 6.67 into 1.6 into 9.1 together, and 10 raised to power minus 11. This is in 9th or 8th class, that a to the power 1 upon a to the power m can be written as a to the power minus m, and a to the power minus m can be written as a to the power plus m. And if we have a to the power x in multiply with a to the power y, then we can write this as a to the power x plus y. This is in 8th class, so I hope you know this. I am writing this thing. Ten raised to power minus 11 minus 27 minus 31, and this is 10 raised to power minus 20, and when this minus 20 will go in numerator, it becomes plus 20. So it becomes this becomes 6.67. I am using calculator. I don't have any calculator, so 6.67 into 1.6, this becomes 6 again 10 10.672, and we have to multiply this with 9.1. 10672 into 9 to the 18 3 9 to the 18 9 60 this is 3 4 16.11 into 10 raised to power minus 11 and minus 27 minus 38 minus 38 minus 31. This is 69 plus 20 minus 69 plus 20, it becomes minus 49. So answer is gravitational force is 16.11 into 10 raised to power minus 49 newtons. We made the mistake in calculation. This will come 97.11 into 10 raised to power minus 49 newton. So be careful in these kind of problems. There are high chances of getting wrong answer. So question number 2 is two objects attracting this question, two objects attracting each other with 32 Newton gravitational force. If distance between them is decreased to 1/5 times of original distance, find new gravitational force. Find new gravitational force. This is the question. Now, in first case, two objects attracting each other with 32 Newton gravitational force. So I can write F1 as G m1 into m2 upon r square. This is given as 32 Newton. In new case, the distance between them is decreased to 1/5 times of original distance, means distance is decreasing. As we discussed, that if the distance between two bodies is decreased, the gravitational force will increase. So we have to see how much gravitational force will increase. So now new distance becomes r2 is 1/5, so it becomes r1/5 decreased to 1/5 times. Now F2 will be, new force will be G m1 into m2 upon, masses are same in both the cases. I can write this as r1 upon 5 to the whole square. So I can write this G m1 into m2 upon r1 square upon 25. So if I have A upon B upon C, so I can write this as AC upon B. I can take this in numerator. Now I can write this as 25 times G m1 m2 upon r square. Value of this is given in the question, 32. So 25 into 32. This becomes 25 to the 50 and 5, 800 Newton. I hope this is clear. Now we will see some more questions. Two objects of masses m and 4m are placed at a distance are placed at a distance are apart, where should where should we place another mass m dash between these two masses so that gravitational force on m dash will be 0 because due to these masses. Now two masses, suppose this is m and its magnitude is given 4m. They are distance, this distance is r. We have to place another mass m dash between these two masses so that the gravitational force on that mass, suppose I am placing this m dash from distance d from this mass m. So it is given in the question, we have to place this m dash at any distance so that the gravitational force on that mass will be 0 due to these two masses. Now look, because of m dash, because of this mass m dash will try to go in this direction. This is mass force on mass m dash because of m, and this 4m will attract this m dash towards itself. So this is force because of mass m, and this is the force because of 4m. So if these two forces are equal, if these two forces will be equal, then net force on this m dash will be 0 because these two forces have opposite directions, and if they have equal magnitude, then net force on m dash will be 0. So I can write force on m dash because of mass m, I can write this as g m into m dash, and distance between these two masses is d square, and f force on m dash because of 4m, I can write this as g 4m into m dash, and distance between these two masses is, this distance I can write as, total is r, and this distance is d, so I can write this as r minus d. So it becomes r minus d square. And if net gravitational force is 0, then these two forces must be equal. So I can write f m dash m equal to f m dash 4m, this m into m dash upon d square equal to g 4m m dash upon r minus d whole square. G to g cancel, m to m cancel, m dash to m cancel. So it becomes 1 upon d square equal to 4 upon r minus d square. I can write this 4 as 2 square. So it becomes, I am writing here, it becomes 1 upon d the whole square, 2 upon r minus d whole square. Take square root both sides, so square 2 square cancel out. I can write 1 upon d equals to 2 upon r minus d. Cross multiplication, 2d equals to r minus d. Take d this side, So 3d equal to r. So r is so d equals to r by 3. So we have to place this third mass at a distance r by 3 from this mass m. Then there will be no net force on that m dash mass. Is this clear? Next question. Fourth question is, we have two masses. This is 1 kg, another mass is 2 kg, and they are at a distance 2 meter apart. Means this distance is 2 meter. This distance is 2 meter, and we have to place a third mass exactly midway between them. Means we have to place another mass midway, means 1 meter, at a distance 1 meter, and the third mass of 1 kg. This is also 1 kg. So in the question it is asked, first part is gravitational force on third mass due to 1 kg mass. Gravitational force on third mass due to 1 kg mass. 1 kg mass means this mass. So force can be written as G m1 into m2 upon r square. This G is 6.67 into 10 raised to power minus 11. M1 value is 1. M2 value is 1. And distance between them is 1 meter. 1 square. This is also 1. So force, gravitational force on this mass because of 1 kg mass will be 6.67 into 10 raised to power minus 11 Newton. Second part is gravitational force on third mass due to 2 kg mass. So in this case force becomes G. Value of m1 is 2 and value of this 1 upon distance 1 square. So this is 6.67 into 10 raised to power minus 11 into 2. 1 and 1 they will not make any change, so it becomes 14, 12, 13, 1, 13.34 into 10 raised to power minus 11 Newton. So force in this direction is 6.67 into 10 raised to power minus 11, and force in this direction is 13.34 into 10 raised to power minus 11. In third question we have to find third case is C part is find net force on third mass and also find acceleration. Of third mass. Net force can be written as sum of all the forces with their directions. F1 plus F2. F1 is, this is origin, means midpoint. So any force which is in left direction we will take that as negative, and anything which is in right direction of this point we will take this as positive, because this is negative x-axis, this is positive x-axis, so it will be taken positive and it will be taken negative. F1 is, I'm taking this as F1, 13.34 into 10 raised to power minus 11 minus 6.67 into 10 raised to power minus 11. So this will come out 6.67 into 10 raised to power minus 11 Newton. In which direction? Towards 2 kg mass. Direction is towards 2 kg mass, or you can say positive x-axis, towards positive x direction. And now we have to find acceleration of this mass. So net force from Newton's second law, we can write this as mass into acceleration. Net force is 6.67 into 10 raised to power minus 11, and mass of this mass is 1 kg, and we have to find acceleration. So you can take this mass in denominator of left hand side, so we will get acceleration 6.67 into 10 raised to power minus 11 upon 1. So this will be 6.67 into 10 raised to power minus 11 meter per second square. This is answer.